Okay, now let's discuss set operations. And so what are set operations? Well, what is an operation in general? If we have operations on number, we have arithmetic operations, plus, minus, that's a minus, a multiplication. I don't know how to do a division sign on this, so, oh wait, no, I'll make a division sign. Division. Great. So these are our, typical operations on numbers. They take two numbers and make a new one. Well, we have the same sort of thing with sets. We have two main operations that take two sets and give us a new one. So the first one of these is going to be called a union. And so if we have sets A and B, the union of A and B is the set that contains all of the elements that are in A or in B or both. Let me just note this or usually means this or that. If I say to you, you can sit here or there, you can only sit in one place. But that's a bad example. You can have soup or salad. You can only have the soup or the salad. You go to a restaurant, somebody says, "Do you want the soup or the salad?" And you say yes. They're going to say no. You only get one. Sorry, buddy. But in math, or means this or that or both. So, generally I'll try to be explicit and say that, in A or B or both, but, if I slip and just say or, I really mean one, the other, or both. Anyways, so we denote this, the union, by we put a sort of a U symbol there, B. Okay, so that is what the union of two sets looks like. And we can also write this out in set builder notation. A union B is the set of all elements X such that X is in A or X is in B or both. Great. So what are some examples of this sort of thing? Well, let's consider, let NYC be the set of counties in New York. So we have the Bronx, we have Brooklyn, we have Manhattan, we have Queens, and we have Staten Island. Now let Long Island be the counties that are on Long Island. My sister was visiting New York this weekend, and she didn't actually realize that Brooklyn is part of Long Island. There's also Nassau County. Queens is part of, if I'm going to call them by their counties, let me at least call them by the right names. Kings, New York County, Queens, and Richmond County. So anyways, Brooklyn is Kings County, and that is, part of Long Island, Nassau County, Queens County, and Suffolk County. Okay. Great. So then, what is NYC, Union, Long Island, at least in terms of counties? Well, what I do is the way I like to do this is I'll start with the first set and I'll write everybody down. So I've got Bronx County, Kings County, New York County, Queens County, and Richmond County. And then I add on to this, I go to the second set and I say, well, what have I not already written down? I already wrote down Kings County. I have to write down Nassau County. I already wrote down Queens, so let me just write down Suffolk County. There we go. This is the union of New York City and Long Island, at least in terms of what counties there are. So just notice that, Kings and Queens are in both, but I only wrote them down once. They're in both, but they appear here. Okay, here's a second example. Let's say that you may or may not know this, but Major League Baseball is broken up into two leagues there's the National League, called the NL, and then there's the American League, which is called AL. And you know, that's pretty much all I'm going to say about that. But let me make up two sets. Let me say N is the set of X, such that X is a city with an NL team, and A is going to be X, such that X is a city with an AL team. Okay. Well, if I take N union A, this I just get all X such that X is a city with an NL team or an AL team or both. Now first let me just note that Chicago and New York have both. Technically Los Angeles also does have both, although the Los Angeles Angels are located in Anaheim, and the people of Anaheim really would rather lay claim to the Angels, so I'm going to just say that Chicago and New York properly have two baseball teams playing there. But if I'm going to say that, then New York has no football teams, New Jersey has two. Anyways, Chicago and New York have both of these. But let's notice that N union A, then I could give it a nicer description. X is just X is a city with an MLB team. Because if you have an AL team or an NL team or both, you've got a baseball team. Okay. So sometimes you can write your sets down in a little bit nicer of a sort of a condition, but generally if you're writing stuff out in set builder notation, you just write both conditions and put an or there. Okay. Finally, let's let O be the odd numbers. So X such that X is an odd number, and E is going to be X such that X is an even number. Then when I take O union E, I get X such that X is a whole number, because every whole number is odd or even. So that's just sort of an example there. How about the next set of operation we have is intersections. And what is the intersection? Well, the intersection of A and B is the set of elements that are in A and B, what they share, basically. And we denote this by and we write this sort of upside down U symbol. I like to call it a kappa. A intersect B, and this is in set builder notation. A cap B is equal to all elements X such that X is in A and in B. Okay, so it's what they share. So again, let's do some examples, and I'm going to rehash some of the examples we did before. If I look at New York City intersected with Long Island, let me just put a space in there to make it look better, I end up with just Kings County and Queens County. Those are the two counties in New York that end up being on Long Island. Now let me scroll up for a second. How do I use the roster method to find an intersection? Well, I go across, say, the first set, and I say, is Bronx in the second set? No. Is Kings in the second set? Yes. Is New York in the second set? No. Is Queens in the second set? Yes. Is Richmond in the second set? No. Okay, so the only two things that get shared are Kings and Queens. Another example we've seen is in the context of systems of linear equations. Remember that I said that I could write a line as in terms of set as saying all the pairs x, y, such that say 2x plus 3y is equal to 1. And let's suppose I'm trying to solve the system of equations that involves this one line and let's see, whoops, 3y. Let's see here what happens when I write it like this. X comma y. Let's x plus y is equal to 1. Okay, so this line intersected with this line, but this is really all xy that satisfy the system, satisfy the system, 2x plus 3y is equal to 1, and x plus y is equal to 1. So to figure out a nicer way of writing down what this set is, we can just go ahead and solve this set, this system of linear equations, and I believe that you can go ahead and figure it out. I can just write down the single point, which is 2 comma negative 1. That is what this intersection is here. One final example, let's remember that O was the odd numbers and E was the even numbers. Here when I take the intersection of these guys, you can't be odd and even. Contrary to what you may have heard, 0 is even, not odd. So when I take the intersection between these two guys, I get nothing. Now this is called disjoint. Two sets which share no elements, i.e. whose intersection is empty. So two sets are disjoint if they share no elements, if their intersection is the empty set. Okay, there's one final thing I would like to talk about, one final sort of relation, which is the complement. But before I get into the complement, let me first define a universal set. So a universal set, which we usually denote by U, is a set which represents everything we care about at the moment. So, for example, if I'm talking about the upcoming election, e.g., if I'm talking about election 2012, and I ask you who you are going, who you think, say, will win, I don't mean like everybody in the United States. I don't mean out of everybody in the United States, I mean out of the candidates. So the universal set here is the set of candidates. The Republican primary candidates, Barack Obama, I think he does have a challenger, but not a very serious one for the Democratic nomination. And of course, there are the smaller parties out there: the Green Party, the Libertarian Party, I think the Naked Cowboy is running. If you want to just vote for him just for kicks, go ahead and do it. I would suggest you don't, because then you're wasting your vote on something silly. Anyways, so it sort of puts things in context. So think of a universal set as context. Okay. So then once I talk about this, then I can talk about a complement. The complement of a set A in the universal set U is the set of all elements in U that are not in A. And we denote it by A prime, and we can write it out in set builder notation as A prime is equal to all elements X in U such that X is not in A. Okay, great. So this little apostrophe, I call it a prime. So here, let me just note that. The apostrophe I call prime. So I say A prime. That is A prime. Okay. Let's do a few quick examples. Again, NYC is the boroughs of New York City, and this will be my universal set. And let me just consider the set A, which is just New York County. Then A prime is the outer boroughs, Bronx, Kings, Queens, and Richmond, which I could say are the outer boroughs. 2, let's say that U is, let's let R be the real numbers, be our universal set, and let's let P be the positive numbers. Then P prime is all numbers X which are less than or equal to 0. And I'm basically out of time here, so yeah.